Have you ever wondered just how big a hurricane can get? We're not just talking about wind speed, but sheer, mind-boggling size. Today, we're diving into the colossal world of the largest hurricanes ever recorded on our planet. These aren't just storms, they're continent-sized weather systems that dwarf entire countries. Let's start with a little perspective. The average hurricane is about 300 miles, or roughly 480 kilometers, across. That's already massive, but the storms we're talking about today make that look tiny. We measure a hurricane's size by the diameter of its gale force winds, which are winds of at least 39 miles per hour, or 63 kilometers per hour. So, let's journey to the Pacific Ocean, the breeding ground for the biggest of the big. The storms here are called typhoons, but they are the same weather phenomenon as hurricanes in the Atlantic. The Western Pacific has a vast expanse of warm water, which is the perfect fuel for creating monster storms. One of the most infamous giants is Typhoon Tip. In October 1979, Tip grew to a staggering diameter of about 1,380 miles, or 2,220 kilometers. Let that sink in. If you placed Typhoon Tip over the United States, it would stretch from New York City almost all the way to Dallas, Texas. It would cover nearly half the country. At its peak, Tip also held the record for the lowest sea level pressure ever recorded at 870 millibars, which contributed to its ferocious Category 5 winds. It was a true monster of a storm, a benchmark against which all other giant storms are measured. But Tip isn't the only behemoth from the Pacific. Fast forward to 2013, and we meet Typhoon Haiyan, known in the Philippines as Yolanda. While Haiyan is mostly remembered for its devastating intensity and the catastrophic storm surge it produced, its size was also immense. It wasn't as sprawling as Tip, but its destructive power was concentrated, making it one of the deadliest typhoons in modern history. The sheer scale of its wind field meant that millions of people were simultaneously experiencing its wrath. Now, let's cross the globe to the Atlantic Basin. While Atlantic hurricanes don't typically reach the colossal sizes of Pacific typhoons, they can still become incredibly large. One of the giants of the Atlantic was Hurricane Sandy in 2012. Sandy was the strongest hurricane in terms of wind speed. It was a Category 3 at its peak and made landfall in the U.S. as a post-tropical cyclone. But what made Sandy so destructive was its sheer size. At its largest, Sandy's tropical storm force winds spanned a diameter of over 1,100 miles, or about 1,800 kilometers. It was an absolute giant, earning it the nickname Superstorm Sandy. This enormous wind field drove a massive storm surge into the coastlines of New Jersey and New York, causing widespread flooding and unprecedented damage. Sandy's size meant its impact was felt across more than 20 states, from Florida to Maine and even into the Midwest. It perfectly illustrates that when it comes to hurricanes, size really does matter. Another Atlantic giant worth mentioning is Hurricane Igor from 2010. Igor was a classic, powerful Cape Verde hurricane that churned across the Atlantic for weeks. While it didn't make a direct hit on a major landmass as a major hurricane, its size was enormous. At one point, Igor's diameter was nearly 920 miles, or 1,480 kilometers. Its massive waves and powerful swells affected coastlines from the Caribbean to the east coast of the U.S. and Canada, even causing fatalities from rip currents, hundreds of miles away from the storm's center. So, what creates these megastorms? It's a perfect storm of ingredients. You need a vast area of very warm ocean water, typically above 80 degrees Fahrenheit or 26.5 degrees Celsius, extending deep below the surface. You also need low vertical wind shear, meaning the wind speed and direction don't change much as you go up in the atmosphere. This allows the storm to organize and grow vertically without being torn apart. Finally, a moist, unstable atmosphere provides the fuel for thunderstorms to build and coalesce into a single, massive circulation. The western Pacific Ocean is the world's most favorable region for these conditions to align, which is why it births so many record-breaking typhoons like Tip. But here's a sobering thought. As our planet's oceans continue to warm due to climate change, scientists are concerned that the potential for these massive high-impact storms could increase. Warmer water provides more fuel, potentially allowing storms to grow larger and intensify more rapidly. We might see the records set by storms like Tip and Sandy challenged in the coming decades.